Let's take a look at a little bit larger example of doing a determinant. The process is the same as it is for a 3 by 3, but we haven't seen it in a larger one yet. So this is a 5 by 5. This is actually example 3 from the book. This is a 5 by 5, and they just say find the determinant. And as I mentioned in the last video, you can do the cofactor expansion across any row or any column that you want. You know what would be a terrible pick for a row or column for this particular matrix? The top row. This, I mean, it would work, but you would have to do 3 times some stuff, minus -7 times some stuff, plus 8 times some stuff, minus 9 times some stuff, plus -6 times some stuff. Not so much fun. Instead, let's make a more intelligent choice and save ourselves some work. I'd rather have 0 times stuff. I like multiplying 0 times things, which to me says either the first column or the last row would be a great pick. Your book, since this is example 3, your book picks the first column. I'm going to go ahead and pick the last row just so you get some variety. Maybe you can see it done 2 different ways. So I'm going to go ahead and do my cofactor expansion using that last row and take advantage of all those zeros. Don't forget the checkerboard pattern of plus minuses. So keep in mind that would start with a plus here, and let's see, then it would be minus, plus, minus, plus, so that'll go plus, minus, plus, minus, plus. So that'll be how my expansions go. So the determinant here would be 0 times, and I'd cross out the first column and the last row, but it's 0 times anything, right? So who cares? 0 times anything is going to be 0. So I'm not even going to write out all the 0 terms. Well, maybe I will pseudo write them out. So you'd get a minus 0 times some stuff, plus 0 times some stuff. But really the only term that matters to us is going to be minus -2 times some stuff, and then finally you'll get a plus 0 times some stuff. So let me sort of reset down here and just write minus a -2, or maybe I'll just skip straight to saying plus 2 times. Okay, so I'm focusing particularly on this term, the only one that's non-zero, and that means I'll cross out this row and this column. So that means I'll do the determinant of what's left. So that means I still have the determinant of, and I'm actually going to write out the matrix here, because so the determinant of 3, -7, 8, -6, 0, 2, -5, 3, 0, 0, 1, 0, and 0, 0, 2, -1. So it's 2 times the determinant of this. How do I find the determinant of this? Cofactor expansion. So 2 times, and for the cofactor expansion here, so this is a whole new little determinant problem to do. Again, first row would be fine, third column would be fine, and again, just so I'm departing from the way the book did it, I will choose the third column. So I'm going to expand along this third column right here. I need to check my checkerboard. So let's see, this will be plus, minus, this is a plus, minus, plus, minus. So really it's going to be 2 times, there'll be some 0 terms, 2 times, the only term that is non-zero here that I'm going to expand by is 1 times, And then since I'm using this one, it's the determinant that I get by crossing out that row and that column. So now it's the determinant of 3, -7, -6, 0, 2, 3, 0, 0, -1. And again, there's some more zero terms I'm leaving out, but that's the only non-zero term. And now I'm finally down to doing the determinant of a 3 by 3. And how do I do that? Cofactor expansion still. Same song. Third verse. Maybe this time I'll just... this guy's been calling out to me, so maybe I'll finally expand down this first column. Checkerboard pattern of plus minuses means plus, minus, plus. Okay, I think we're almost there. So 2 times 1, 1. 2 times 1 times the determinant of this 3 by 3. Again, normally the 3 would just be the first of 3 things, but the other 2 are 0. So 3, and now I'll cross out this, and it's the determinant of 2, 3, 0, -1. And finally, that's a 2 by 2, and I know how to do that determinant directly. Let's see how many print. 1, 2, 3, 1, 2, 3. Okay. So finally here I've got 2 times 1 times 3 times the determinant of a 2 by 2, and that's AD minus BC. So 2 times -1 minus 0 times 3. So just 2 times -1 or -2. Okay, all that to say that all we're really doing is multiplying these 4 numbers together. So 2 times 1 is 2, times 3 is 6, times -2. Whew, finally, determinant of all that comes out to -12. Which does mean, and this is incredibly hard to visualize unless you're a pan-dimensional being, so if you were to plot these 5 vectors, plot each one of them in 5-dimensional space, and get the 5th-dimensional parallelepiped, that its volume, its hypervolume, would be 12, and it also would have flipped over from its original orientation, so it'd be -12 for its volume. Okay, I think we're done with that example, but this example points out an important fact that choosing the right row or the right column saves you a ton of work. I really ended up only having to do ultimately one determinant, right? 1 2 by 2. But even aside from that, I sort of had to do 1 4 by 4, 1 3 by 3, 1 2 by 2. Which is much better than having to do 5 4 by 4s. And each one of those requires some 3 by 3s, right? So don't do it that way. So let's leverage that with one more example. So let's take a look at doing the determinant for this one. This one has a bunch of zeros, and I'm going to take advantage of that. So let me just take the obvious one here. Let me just take the first column, and the plus minus pattern starts me off with a plus. So the determinant starts off with 2 times, and then I'll cross out that row and that column and say it's the determinant of the remaining 3 by 3, which I won't rewrite over here, but I'm just going to say for that 3 by 3, let me choose the first column again. Right there. And keep in mind, I'm doing a brand new determinant on a 3 by 3, so the checkerboard pattern resets. For the 3 by 3, it goes plus, minus, plus. So it's still plus. So it's going to be -1 times And since I'm picking -1 and the other two are 0, so now it's just the 2 by 2 determinant, which is 1 times 2 minus 4 times 0. So I'm going to say 1 times 2, technically minus 4 times 0. But notice what happened here. All I ended up with was the product of the numbers on the diagonal. 2 times -1 times 1 times 2. The only reason I could get away with that was there was always zeros below the main diagonal. If some of those weren't zeros, then I would have had to add at least one extra determinant in here. But with all those zeros below, the determinant is just the product of the main diagonal, which in this case, let's see, is just -2, -4. So this is worth pointing out. In general, it's always true that a triangular matrix, and keep in mind that triangular matrix can mean either zeros entirely below the diagonal or zeros entirely above the diagonal, one of those two. A triangular matrix, the determinant is the product of the main diagonal. And we'll make use of that more in the next section. Okay. So if there's any problem in your homework that is a triangular matrix, just multiply down that diagonal. And if it's not quite triangular, definitely pick the best row or the best column to make your life easier. There's a couple homework problems that give you sort of a shortcut for a 3 by 3 determinant. That shortcut's kind of nice to know, especially if you're going to do cross products at some other point in your mathematical career. But it doesn't work, it doesn't generalize. It doesn't go to 4 by 4 or 5 by 5. It's just 3 by 3. The other thing you're going to encounter in your homework is a couple homework problems that foreshadow the next section. And they help you figure out how does a determinant change when you do row operations on the matrix. Like if you swap two rows, what does that do to the determinant? Or if you add 2 times row 1 to row 2 and make that your new row 2, what does that do to the determinant? The reason that's a helpful question for us is if we could turn all matrices into diagonal matrices using row operations, the determinant would become very easy. So again, we'll look at that more in section 3.2. So for now, go ahead and tackle that homework, and we'll see you in the next section.